In Part 4 of Lecture 6, we discuss monitors. In addition to semaphores, there is another high-level synchronization mechanism proposed, called monitors. Monitors are the brainchild of Hoare and Brink-Hansen. Monitors use two primitive operators called wait and signal that use conditions that are explicitly set to true and false. Unlike semaphores, there is no integer variable to increment or decrement, although these may be used to determine when we wait and when we signal. Monitors implement mutual exclusion automatically. Only one process is allowed to be active in a monitor at any given time. Here is an example of what a monitor looks like, written in a form of concurrent Pascal, the language that Hoare and Brink-Hansen used. The condition is said to be full or empty instead of true or false. We have an integer variable count, which is global for the monitor and accessible by all its procedures. When we enter, we check to see if count is equal to n. If so, we wait until a process signals that the buffer is no longer full. We enter the item, increment the count, and if it now equals 1, we signal that it's no longer empty, and a process that is waiting for a buffer with something in it can now get back to work. Remove is the complement of enter. If the count is 0, we wait until there is a buffer with something in it. Then we take out the item, decrement the count, and if it's n minus 1, we signal that there is now an empty buffer that is available to be filled. The last line at the bottom is the initialization block, where we initialize count to 0, indicating that initially there are no buffers that have anything in them. The producer process simply produces and then uses the monitor to enter its contents into an empty buffer, waiting for one if it's necessary. The consumer process is essentially the same thing, except we remove an item, waiting if there's nothing yet to consume, before we consume it. We can use a similar approach to the dining philosopher's problem, except that there are 5 items to keep track of and 3 conditions: thinking, hungry, and eating. Pickup is one of the monitor's procedures, where we set state for this philosopher to hungry. He has stopped thinking, but he hasn't started eating yet. We test to see if our guy is hungry and has both of his chopsticks available. If so, he takes them and signals that he's eating. Otherwise, he waits. In putting them down, he resets his condition to thinking and uses test to let the other philosophers know on either side that the chopsticks are now available. Testing involves seeing if philosopher K is hungry and has chopsticks with which to eat. If he or she does, we set his or her state accordingly, and if not, we fall through. His or her state not being set to eat will let him or her know that he or she will have to wait to pick up a chopstick. In our initial block, we expect all our philosophers to think, therefore we set their states accordingly.